assignment was to show choose 3 ways to show 3/10. And we're gonna share 4. There's a lot of ways to do it, but there's 4 that we're gonna share today. Okay, we'll start with Tony.
I did 30 100ths equals 3/10 because 3/10 is 30, and you can't do 30/10 because that's tenths, so I converted it to hundredths.
How did you convert it to hundredths? How did you get from 3/10 to hundredths?
I just did 3 times 10 and 10 times 10, and that equaled 30 100ths.
So 10 times 10 equals hundredths, and 10 times 3 equals 30. Okay. Why don't you tell us what you did?
I did a number line, and then so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I counted to 3, and that's 3/10.
Okay. She started with 1/10. Would be here. This would be 0. Like if she put a little mark here. 1/10, 2/10, 3/10, and then she marked it.
I did 0.3, and I got it because if you convert 3/10 into a decimal, it's 0.3, and then you can add as many zeros as you want.
Okay, so he said that he converted this to a decimal. It would be 0.3, would show 3/10. And you can also put a 0 after because it would be the same as what Tony did, which was 30 100ths. This is 30 100ths, so it still works.
What I did is I did a model, and I did 10, and then I colored in 3 for 3/10.
So there was on the piece of paper, there's that one that's already in tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So she colored in 3 of them that way. She also drew her own model this way that showed tenths, and then she shaded in 3. How many of you did one of these as an example? Okay, that kind of leads us into today's lesson, which is 9-7. The city park covers 0.64 square miles, or 64 100th square mile. About 1/1800th of the park is covered by water, and about 2/10 of the park is covered by paved walkways. Is more of the park covered by water or by paved walkways? So we're comparing. Ask yourself, what are we comparing? What is the question asking us, and what are we comparing? Raise your hand when you can tell me. Okay, so we're comparing the water and the paved walkways. So there's more information than that in this problem. Who could tell me what the extra information is? What's the extra information, Malia?
The top where it says city park covered 0.64 square miles.
Correct. If we are just comparing how much of the park is covered by water and how much is covered by paved surfaces, or paved walkway, the area of the park doesn't matter. So I'm going to cross that information off because I don't want to get confused by those numbers. The numbers I do want to use are 1/1800ths and 2/10. Now, using a model, I can compare these. Looking at them, how many of you feel like just looking at them you would say, well, 18 is more than 2? I mean, honestly, we look at decimals and we think 18 is bigger than 2. It's greater. But when we compare decimals, we're not just looking at, we're looking at the total number of digits, and I'll explain what I mean in just a minute. First thing I want you to do, shade 1/1800ths right here. Okay, who would like to explain to me what that should look like? Sophia. 1/1800ths. Now go ahead and shade 2/10 on the other one. And Helika, what am I going to shade on this one? 2 what? 2 of these. Comparing the shaded part here and the shaded part here, can you tell which one is greater? Looking at it, you can tell that it's greater, just the visual alone. Now, another way to do this that might be less confusing, because here you're working with hundredths, and here you're working with tenths. I'm going to, on the opposite side of this, I'm going to shade what those 2/10 look like, because I know how to do tenths on 100 square also, don't I? So I can compare them right on the same thing to see what they would look like in this case. Can anybody explain to me why 1/1800ths, even though it's a larger number than 2, is a smaller number than 2/10? So how is this possible when 18 is a larger number than 2? Okay, so she said, and I'm going to repeat it so you can hear. She said if you were to pretend that this was in tenths, you don't have 2 whole tenths. Okay? Is there another way to picture that or visualize that? Okay, so you're talking about if we split this into like this. He's saying that the smaller the denominator, the bigger the pieces. So these pieces are smaller, and that's correct. I'm jumping a little bit ahead. Let's go ahead and look at the next part, and then we'll talk more about it. Okay, we're looking at the number line. Locate 18 hundredths, and 2 tenths on a number line. So looking at this, I can see that it's broken down into hundredths. How many hundredths are at this point right here? 10 hundredths. How many hundredths are at this point? 20 hundredths. So to find 18 hundredths, I start at 10 and say 11, 12, 13, 14, 15, 16, 17, 18 hundredths right there. Go ahead and mark yours. Now I'm going to mark my 2 tenths. Where's that going to go? Who could explain to me where I'm going to mark that 2 tenths? Oh, so right here, 1, 2. Okay, how many of you agree with that? Who thinks they have a different answer? Haley?
Put it at the 20.
At the 20. And why would you put it at the 20?
Because 2 tenths is equivalent to 20 hundredths.
Right. 2 tenths, remember we did as one of the examples on choose 3 ways. We said that 0.3 also equals 0.30. I think that was what Nicholas had shared. Remember? So 0.2 is equivalent to 0.20. 2 tenths is equal to 20 hundredths. 0.18 is closer to 0, so 0.18 is less than 0.2. You can just simply compare the size parts. Remember when we're doing fractions, one of the ways we can compare them is to make sure that they have the same size parts, meaning the same denominator. You can do the same thing with decimals. Okay, so what's another way to change 0.2 so that it has the same size parts? What do you think, Ebony?
So just like our other lesson, so you can make 0.2 into 2 tenths and then multiply it by 10, which equals 20 hundredths. So it would be 20 hundredths and 18 or 0.8.
Okay.
I mean, it would be 0.20 and 0.8.
There you go. So that's what he just explained. You can change the 2 tenths to be 20 hundredths. Okay, and now we're comparing 18 and 20. When you compare 18 and 20, do you know which one is greater? Yes, you do. 18 hundredths is less than 20 hundredths, so 18 hundredths is less than 2 tenths.
So it goes in 1.
You can change the tenths to hundredths by adding a 0, because we multiplied by 10. So more of the park is covered by. Now I've done all these numbers and I've done the greater than and the less than. I have to go back to what was the question. The question was, is more of the park covered by water or paved walkways? Which one of these numbers represented the water?
0.2.
So this was water and this was paved walkways. So which one, it says more of the park is covered by which one? Paved walkways. There you go. You can compare numbers written as decimals by using place value. It's kind of what I was talking about on the last one. Comparing decimals is like comparing whole numbers. Always compare the digits in the greatest place value position first. So if Tim has 5 tenths a dollar and Sienna has 5 hundredths of a dollar, who has more money? So we can do the model. I want you to model Tim's and model Sienna's. Go ahead and do it on your own. Who would like to explain to me how they modeled Tim's? Rachel, how did you do Tim's?
I did
5 columns? 2, 3, 4, 5. Okay, there's Tim's. Who would like to share? Aaron, why don't you tell me how you did Sienna's? 5 little squares. Okay. So looking at this, who has more? Everybody. Tim. Look at the place value model. If we took those decimals, 5/10 and 5/100, and wrote it in a place value chart, we have 0 ones, correct? And we have the 5 right after the decimal point in the 10th spot. We would call that 5/10. We know that. How many hundredths do we have? 0. So I can put that. Remember. Now I'm going to do Sienna's. We have 0 in the ones place. What's in the 10th place? 0. And then the 5 is in the hundredths place. Just like when you're comparing whole numbers, you always look on the left side first to see which one is greater. So if we go the furthest, which one of these is greater? None. They're equal. Which one of these is greater?
5.
The 5/10. So that tells me right away that Tim has more. Okay? 5/10 is greater than 0/10. So 5/10 is greater than 5/100. Compare the size of 1/10 to the size of 1/100. Just looking back up at your chart up here, you can compare 1/10 to 1/100. If you can compare those, you can easily compare 5/10 to 5/100. Explain how being able to see the size of one of these compared to one of these helps you compare 5 of them to 5 of them. All right, go ahead and write in words how that helps you. The 10th size is huge compared to the 100th size. So 5 of these is definitely going to be greater than 5 of those. Go ahead and shade 1.3 or 1 3/10. Shade it right here. Kind of do it like that. Okay, one whole one there.
And then you fill 3 lines.
Okay,
And that's
1.3. Okay, so this would be all in. Let's just pretend like that's all shaded. On this side, I'm going to shade 0.6 or 6/10. Go ahead and shade that right now. 6 lines. So 6 of those. Looking at those, can you compare those two numbers? Okay, which one's greater, class?
1.3.
1.3 is greater.